Hello folks, so in this video we're going to talk about this problem right here using a system of equations to model a situation. This is a really interesting one because actually you don't need a system to answer some of these questions and to model this situation, but in this case we are going to use a system. Alright, so in this situation we have Souffle and Casserole opening up some burger stand like McDonald's stand or a Burger King stand or something. And it's going to cost them $20,000 just, to get the license and to open it. And then for every 1,000 burgers they sell, it's going to cost them $250 in expenses. So ingredients, plus if we kind of consider all the maintenance that has to be done on the restaurant and so on. Let's just keep it kind of simple there. And we also know that they sell the burgers for 75 cents each. Alrighty, so let's, again, with any word problem, let's sort out the important information. This is not actually important, but I do just like the names that these old textbooks have. I wish I was as punny as they are. But we also know, that's actually important, the initial cost of the stand is $20,000, plus every 1,000 burgers they sell costs them $250. And so this really tells us, let's see, $20,000 to open, that's almost always going to be our y-intercept, because that doesn't change. Oops. Sorry about that. The y-intercept, because again, it doesn't change. But what does change is, how much money they're going to have to spend making these burgers. And so this $250 per 1,000 burgers, I'll say. 1,000 burgers. You can definitely assume that that's going to be important. And we haven't even actually got to the questions yet. We also know that they sell the burgers for 75 cents each, so that's probably important as well. They have to, this is important to emphasize, they're paying $250 per 1,000 burgers. And we make 75 cents per one burger. Let's keep that, per one burger. Okay, so let's actually get into the questions now. So we're going to call R of X. And again, the reason we're using R of X is because we're going to use another function to model something else. R of X is the revenue brought in by selling X 1,000 burgers. And so we want to write an equation for R of X. And this is really important though. We can't actually write this equation if we don't know what X represents. So we know what R is, that's the revenue. But this is kind of hidden in that we need to figure out what X is, and that's what X tells us. So right here, I'm going to say X equals the number of burgers sold. Burgers sold in thousands here. So that's really important to note how you're counting them. So when X equals 1, that actually means or refers to 1,000 burgers. Alrighty. So this is the revenue. Remember, the revenue, in case we're not familiar with the vocab here, the revenue, that's money earned. And it's kind of said there in the sentence, I suppose, money brought in. But it's the money you earn. So let's think. I can start off with like a little table here. If I don't sell any burgers, well, we're going to assume that they only sell burgers. They don't sell like sodas or anything like that. Then they're not making any money, right? They're not making any money there. If I sell X equals 1, so X equals 1, remember, means 1,000 burgers. This actually means 1,000 burgers. Well, again, let's see. How much money did I make? Well, we know that we earn 75 cents per one burger, but we sold 1,000 of them actually. So to figure that out, I'm just going to take this and multiply it by 1,000. And this kind of helps, I write it out like this because it helps my units kind of, I can see the units canceling out. And so burgers and burgers will cancel. Oop, that's dollars right there. And so I'm thus left with 75 cents times 1,000 actually is $750. And if I sell another 1,000, I'm going to make another $750 and so on. And so we can see here that actually R of X is simply going to be this many thousands of burgers. Let's see, how many thousands of burgers times basically the price of 1,000 burgers. So this is 750 for 1,000 burgers. So that 750 there is the slope, or again, it's basically the price, the cost of 1,000 burgers. I realize it's the same word across, written out over and over again. Okay, so that should be R of X. Remember, this is how much money you bring in based on the number of burgers they sell. Alrighty, so if I want to figure out what R of 50 tells us, and in the book it tells us about a bunch of these, but let's just focus on R of 50, I would just have to throw that in. So R of 50 would mean that I just plug in 50 for X. I'll get, I should be, let's see, 100 times 750 would be like this. I'm going to multiply by 100, and I'm going to divide it by 2, because that's a little bit easier just for me to do. And so let's see, this would be 750 plus 2 more zeros, divide by 2. So that would be $3,750. Right? So that would mean selling, again, think about we're linking this back to our situation, selling 50, not 50 burgers, but 50,000 burgers earns us, or I'll say brings in, also, I suppose, brings in $37,500. All right, moving on then, let's talk about the cost of the stand, because not only does the selling burgers make money, it also costs us money. So if we look back here, let me make some more. Okay, so I've made a little bit more room. I apologize for that. So we want to find out now how much it costs. Well, remember, we first have to spend $20,000 just to open the stand, but that doesn't change. And then it costs us $250 per 1,000 burgers, per 1,000 burgers. So really, we see the flat fee for just opening it, and then this continuous rate. So that is going to be our slope here. Slope, and that's our y-intercept. So nothing too crazy here. Our equation, C of X is equal to $250 times the number of burgers plus $20,000. Oh, I just really want to emphasize what this says again. This is the total cost of the burger stand. That's why it should have it should have a positive slope, because it's costing more. I saw a lot of people thinking that it should actually be going downward because they're used to, well, if I'm spending money, then I'm losing money, so I have to go down. But this, if we think about what the dependent variable or the output is, we can kind of keep ourselves in check. If this was something like how much money you have, then yeah, it would be going downward because I'm shelling out more money, or I'm in debt. But in this case, we're just looking at the cost kind of in its own vacuum. And so that's why the cost should be going upward. Now, if we want to evaluate C of 50, just like before, C of 50, we'll just throw 50 in for X. 250 times 50 plus 20,000. Let's see, I'll do kind of what I just did before. 250 times 100 over 2. My brain's not really working today, so that's why I'm doing this. Let's see, 250 times 100, so let's see, 250 plus 2 more zeros over 2. And that's going to equal, let's see, 12,500 plus 20. And I'm just going to bring it up here for one last line. C of 50 is going to equal $32,500. Okay, so now let's actually graph this just to see what's happening here. If I remember correctly, our equation for our revenue is 750x, And our equation for the cost is actually going to do it in purple here. Our cost is, let's see, what did we say? 250x plus 20,000. So I'm actually just going to pull up the graph in Desmos and then paste it here. Okay, so I've plotted our lines in Desmos here, and again, the red line here is r of x, which is 750x, and the purple line is c of x, our cost, which is 250x plus 20,000. And we can see here that, again, we know that the lines are going to cross 1 at some point because their slopes are different, right? The red line has a lower y-intercept, the y-intercept is 0, but it's growing. It looks like 3 times as fast, actually. 750 versus 250. It's going 3 times as fast as the cost. So, of course, at some point, they're going to end up making money. And we can actually see this based on what we had done previously with c of x and r of x. And I'll just highlight those here. Or sorry, c of 50 and r of 50. Because notice, when you first open, they're in debt, right? Because, again, the purple line right here, if I just kind of compare this right here, g of x is greater than f of x. Sorry, r of, I'm using c and r, excuse me. C of x is greater than r of x. And that tells us that we are in debt, right? Because we've spent more than we earned. But as you keep going on, the difference here, the amount of debt that you're in, is getting smaller and smaller. Because we can think of this profit, I'll say, would be equal to the money you bring in minus the amount of money you're paying, right? Revenue minus the cost. Another way to think of it, if you think about it in terms of like debt, the debt would be how much you spent, c of x, minus the money you've earned. In other words, cost minus revenue. Excuse me. That's kind of beyond the scope of the question here, but I just wanted to show you how we could actually use either of these, to actually kind of combine the two equations and actually deal with this problem with just one. But if we move on to what this tells us now is that once we saw that, hey, wait a minute, after I've sold 50,000 burgers, I've made $37,500. And after I've sold 50,000 burgers, it cost us $32,500. And so what this means is that by this point, by the time and by we mean souffle and casserole, we've sold 50,000 burgers. We're now making a profit. We are now profiting from our burger stand. Profiting, I think profiting has 2 T's. Maybe there's only one, I don't know. And that we can see that because, again, the cost equation starts off greater, the cost function starts off greater until we get to at some point here, and then after that, our revenue is greater than our cost. So the question is now, where is that? Now, since I've graphed it so neatly on Desmos, we can actually already see that it's going to be at 40,000 burgers, but let's just confirm algebraically. How many burgers do we need to sell? Oops. Let me bring this up. How many burgers do we need to sell in order to break even? I'll just answer the question right here so we can see that it is actually 40. But remember, that would mean r of x and c of x, would have to be equal to each other. Because at that point, we've paid off all our debt, but we haven't made any money either. That's what break even means. Break even, again, that just means cost equals revenue. Okay, so let's just solve this here. Now, again, the nice thing about these two equations is that they're already in slope-intercept form, so we can just set them equal to each other. Set their outputs, or their dependent variables, or y, equal to each other. So I have 750x And I'll do this one in purple just so we can see actually. C of x, 250x plus 20,000, subtract 250, I'll get 500, x equals 20,000. We'll divide by 500 and you'll get x equals 40. And so this would mean, again, not 40 burgers, but actually 40,000 burgers. All right, so that is an example, and I think it's really cool one because I actually really like this problem because it really makes you think about what these equations are, and you really have to know, hey, sorry, I reordered the thing so it all messed up, but how do what the actual variables represent affect our equations and how we tackle the problem. Thanks for watching, folks. Stay spicy.